Okay, welcome back. So after looking at this question data set and trying out this simple idea of generating Sparkle queries, let's go back to IBM's Watson, which was a very successful question answering system. Remember, at 2011, it won the Jeopardy competition. And since then, it's become used in multiple applications by IBM. For example, you can also develop chatbots online using Watson as the backend. Of course, you're going to pay a lot more if you use IBM Watson than when you go with a Montreal startup. So let's see how Watson does it. Now you understand a lot more of the technique. You know about NLP, you know information retrieval, similarity, you know about knowledge graphs. And Watson does all of these steps. It analyzes the question, breaks it down using NLP. It has multiple strategies for finding the answer, which it explores in parallel, and then it scores the possible answers to come up with the best one. And this is the answer it gives. So even 10 years ago, it had quite impressive hardware running behind it because it had to analyze and answer the questions in real time, and it didn't have any online access. This was all in memory. And even the information like the knowledge graph couldn't be retrieved from hard drive or SSD because it would have been too slow. So it was running on 16 terabytes of RAM, 16 terabytes, not 16 gigabytes. So that's even today, nothing you can try out at home on your own laptop. There is a very nice description of the process where it shows for an answer that came in Jeopardy, the individual steps that Watson goes through to answer this question. And of course, this is one that was answered correctly. But have a look at this video. It's quite nice to see how it works. You can pause my video here if you want to watch it now. We only have a few slides left, so I'm not going to make another lecture video. So just to conclude this first introduction to bot design, how do you go about developing a bot? Of course, again, let's say you want to work on bot development. You can work on this in different roles. You could work as form of a startup company that makes a bot framework for different people. You could work on the client side. You work with a specific business that wants to have a bot done, and then you decide which technology to use. Or you could work as a kind of a consultant to help clients navigate the different service providers of bots. But one thing that's interesting is in terms of software development, starting designing a bot from the beginning is emerging as a new software development discipline. Some years ago, people talked about mobile first as focusing on designing something with a mobile device from the beginning, as opposed to starting from a web page that already existed and then trying to fit it onto a mobile device. And similarly, now people talk about dialogue first or speech first, where people want to develop a new solution with the idea that it's developed in form of a chatbot. It's still relatively new in terms of methodology, but one common technique that's used also in chatbot design is writing user stories, where you have a whole set of pairs of user questions together with the expected answers. And then once you've written down a lot of these questions, you can start generalizing. You can put multiple stories together that have the same theme, and then use this as a basis for developing the bot using one of the techniques. When you go to development, you have to look at the question and think about what kind of bot technology would be able to answer these questions. So you have learned some of these techniques, and different techniques need different data to work on them. So remember, these are the four technologies we talked about. Well, we didn't talk about the last one. This comes later on in the course, but we talked about grammar-based bots. So these simple pattern matching approaches. This is very easy to start. And there's also no danger that the bot is going to give you answers that the user wouldn't like, because it can only answer what is inside the templates. But you can also know that these rules are very limited. You cannot write rules forever. And at one point, the rules might interact with each other. That the wrong rule is picked because of the regular expression matching, and then the whole system becomes brittle. We've seen the grounding-based bots. So here we can answer complex questions very well. And again, they are somewhat restrained, controlled, because they only answer things that are in the knowledge graph. Of course, they also have difficulty, because you have these graph-based answers. The answers are kind of limited to what is in the graph, and well, they give you answers in these different categories, but otherwise don't have any personality. So this is what's meant by sounds artificial mechanical. You need large-scale knowledge graph to make these work. So you've seen that we have a lot of data available on the linked open data cloud. But if you want to develop something for a new domain, maybe specific for a company, then you have to build this graph first to be able to run the bot on it. We talked about the retrieval-based bots, and these are very easy to work with, because all you need is the training data, the answer pairs, question answer pairs. And if your answers look like a human answered, for example, for a number of questions, then the bot will sound just like a human. However, because of the simple retrieval approach, first, it cannot answer any factual questions. It can really only answer what appeared in this question answer set. And yeah, again, they can't keep any context information. Each new question is retrieved based on the input and not on what was asked before. And that can lead to strange results, to incoherent answers. Basically, you cannot have a follow-up conversation on clarifying a point that came earlier or asking for more information about the previous point. This is something a grounding-based bot could do. It could give you more information about an entity it retrieved earlier, but a retrieval bot can't do that. And finally, we have these generative bots. So people experimented with this before with machine learning and statistical techniques. Nowadays, when we talk about generative, we typically talk about the newest generation, which use deep learning techniques. The idea is that basically, again, you have a corpus, they analyze it, and they generate new text that is somewhat similar to what they have learned. However, in this kind of approach, it's very difficult to have a guided conversation. They can just generate anything, and very often what they generate doesn't make much sense. So you need a lot of data to train, and they can easily go off the rails. Remember the Microsoft Tay bot that was learning from stuff the user told it, and it didn't work out so well, if you remember. But again, we'll talk about this category in one of the next weeks. So there is another task to conclude the worksheet, going back to the first task. And the only thing we have left is talking about what you should read for this lecture. And in another book you can get online, the Natural Language Processing and Action, there is a nice chapter where I used some of the material here in the lecture, chapter 12 on dialogue engines. And then for these two specific topics, have a look at these two references here. So in this book, chapter 8, You can look more at the question answering system from the retrieval perspective, and for some general philosophical foundations and discussions about what an AI agent can do or should do, have a look at chapter 26, which should be available, if it isn't already, as a scanned chapter on the course reserves. And again, don't forget to work on task 7 and have a look at the video about Watson. And I will see you again in the next lecture. Bye-bye.